Good morning, this is Jean-François from Chrysalide Engineering. This circuit was designed to control a single output, provided that we have a power supply 12 volts, or can be used for something different like 6 volt or 24 volts, and a controlling input that is the ground or the same as power supply. Say we have 24 volts or 12 volts as in this case, and we want to control through a single PNP Mosfet. And the solution that was found in this case is to reference the microcontroller from the V+, the power supply voltage. That is, if we have a 12 volt supply, we can simply make a ground one, that is minus 4.3 volts, from the supply voltage, about 8 volts, and through either having 12 volts or minus 4.3 volts from the supply, we can control the PNP. Given the VGS will be 0 volts or minus 4.3 volts, this MOSFET will work. It will be fully saturated. From minus 2.5 volts, it is conducting. At minus 4 volts, it is saturated up to the current we need. So this simple MOSFET, PNP MOSFET with minus 2.5 volts of VGS can be used. We have alternates over here. And microcontrollers with surface mount SO8 package, such as these two, can be used. Although if we use the WCH microcontroller, we'll need to make sure the resistor value over here is correct and the capacitance is also correct, because the circuit is tuned for the STM microcontroller. So how do we work with this? We provide a minus 4.3 volts ground one. We need this current to be a factor of 2, for example, superior of from the microcontroller supply. And we need a good decoupling capacitor. So we can use, for example, 2.7K and 2.2 micro. We can use 10 micro over here and decrease a little bit the resistor if we use more consumption on the microcontroller. And we need to limit this voltage, the supply voltage, the control pin input voltage, to 12 volts or 8 volts through this limiting protecting diodes. But the internal PC2 port has also its internal protection diodes, so this is not really required to have these protection diodes over here. If the microcontroller has been properly tested, we can spare them. We have the programming port that is standard for this type of microcontroller. And we use the 2 pins output from the drain of this MOSFET. And this is a very, very simple circuit, but we just needed this resistor over here to put a clear state on the input. And for information, this is a 4.7K. We limit also and protect at the gate with a 2.7K. We want this as a default off output, 100K. Additional protection limiting the current on the control input, 100K. Decoupling for this pin, 0.1 micro. Decoupling on power supply, 2.2 micro. Protection diodes for the port, 1N4148. And a super simple circuit which is flexible and can be used for 24 volts, provided we will check the components and update some of them as needed, given the supply voltage and current, if we want to update this circuit. And the base is cheap and usable up to standard 24 volts. It was tested at 24 volts, but the use case for this circuit is only 12. If you find this interesting, you can always learn from these couple videos and tutorials I provide. Share information in comments, subscribe, or get involved with some of the products we manufacture. You can see the LC website here under and Electro link also. Thanks and keep in touch. Bye-bye.